Hey everyone, welcome back to the channel. My name is Darsh Joshi and I'm a BTech Computer Science and Engineering graduate and I'm currently working as a developer at a company. Where is the intro? That we can focus more on the topic, which topic for today is abstraction. Python, of course, because we are learning oops in Python right now. Let's begin with abstraction. So what is abstraction? Abstraction is basically hiding the complex internal details and only exposing what's necessary. The user does not need to know how something works internally and only how to use it. So a better example for this would be what an object does, and not like just focus on what an object does, but don't really give a damn about how it does it. So a good example for this would be car. To drive a car, you don't need to understand how the engine works, how brakes work, how accelerator works, etc. Whatever the parts of the car are. You just need to learn how to drive. You just need to learn how to use it. You don't really need to know how the internal functions work. That's the core concept of abstraction. The base class, abstraction base class, abstract base class, whatever you like to call it. We'll just call it ABC. This class is more like a blueprint, the sort of blueprint of whatever thing can make regarding this class. And the thing is that it cannot be instantiated. That means that we cannot create any instances of this ABC, and it only defines the methods which will be implemented. Take a look at this. This is the next topic, creating an abstract base class. We have it. Wait for the operation overloading video, which was create an ABC. Need to create an ABC. Import the library ABC. What I'll do, import that from ABC abstract method. This one. Now what I'll do, I'll define my class. Let's take an example of shapes that I've done in the. So what we'll do, class shape, and what is this? It's an abstract base class. Now inside this you will use an abstract method decorator one. Then we'll define our method which we have, the area, because it's shape. For now let's do this, that we are only laying out the layout for this, not doing it in the entirety of it. So this is your very basic abstract base class, and we cannot make instances of this class. We try to do this, would throw an error. That's not something that's possible. Can't instantiate abstract base class without an implementation for abstract method area. Yeah, that's how it works. It doesn't allow us to create an instance of the shape class. If I create another class, let's say rectangle, it would be child class of this. Let this, if I do def area, then I can do what got suggested and tap. This is possible, but because this is a rectangle and I have not written anything here, what I'll do, I'll take a length and a width. What I'll do is return L multiplied by width. What we'll be doing, just go with it, call this class. Yeah, just print out the area for this. with length, let's say 4, 5, yeah, should be 20. We are getting the 20. This is good, which means that it's working perfectly fine. If I want to make another shape, let's say a circle, then what I'll do, I'll just place this for now. Place this circle. Place this with a symbol R. R is radius, and the formula for area of a circle is 3.14 multiplied by radius. So if I do it now, circle, and we'll print the area of a circle. Copy it. Correct will work. Git, run this, and we are getting the output 50.24. Be accurate because not sure. Yeah, Python is, I think it would be working perfectly fine. Yeah, that's basically how we make a subclass of it, child class or subclass, whatever you like to call it. And this is how we implement the subclass into generating the area in this. It can be anything we want. That was the next slide. I explained it briefly. Why I have not written here anything is because I wanted to show it practically. I did. Move to the next slide. So why do we use abstraction? Abstraction basically ensures that all related classes follow the same structure as we saw in the case of VS Code. In case of shape, all shapes, all child classes follow a similar structure, which is it has a method area. Yeah, that's basically how that's what abstraction does. It enforces a structure. It also makes the code easier to maintain and reduces the chances of missing important methods, which concludes all the other 3 points. Yeah, let's move to the next slide. Code challenge for you guys. We do this here on this channel. I give you a code challenge. You have to complete it and just post your code in the comments. I'll go through them for sure and consider it in the video if it works perfectly fine, or even if it doesn't, I would consider it for a video, because why not? Give me content. Yeah, I'll be correcting them as well. Yeah, it's a different situation for you guys and for me. I get content, you get trained. Yeah, code challenge. Code challenge is to create a rectangle, a circle, use list comprehension to store the values, and we need to calculate the total area in a single expression, the total area of the rectangle and the circle combined. Yeah, that's your code challenge for this video. Conclude the video so that I can move on to the next one, which is position versus inheritance. A lot of time to make. Why not? Yeah, abstraction basically hides complexity and forces a structure. Abstract base class defines required methods. That's it for the video. Please subscribe to the channel. We already have a course out. It's called Python for Absolute Beginners. It's a really good course. It's a beginner's guidebook to Python. If you are new to Python, please go through it. If you are experienced, please go through it as well and suggest me some corrections or changes in my teaching method. Criticize. Anyways, we can also go through this specific playlist which we have, Oops in Python. It has all the videos I have uploaded so far. So yeah, please go through that as well. Yeah, that's it for the video. Next one. Then keep learning, have fun. Subscribe to the channel as well.